And 3, 2, 1, fire. Hello. I'd like to discuss the energetics of the methanol-oxygen reaction, the oxidation of methanol with oxygen to produce carbon dioxide and water. And in a previous video, I showed the explosive reaction. It gives off a lot of energy, and I'd like to discuss why it gives off so much energy and why many oxidations of hydrocarbons or alcohols give off so much energy, I should say. All right, so let's kind of picture what's going on by considering two methanol molecules. We use two so that we don't get fractions in the equation. Two methanol molecules reacting with 3 oxygen to produce 2 carbon dioxide and 4 water molecules. And to account for the energetics, let's imagine that we could take the 5 molecules here and break the bonds apart into individual atoms. So we're going to break the 2 OH bonds, the 2 CO bonds, the 6 CH bonds, and the 3 oxygen-oxygen double bonds. All right. Now, if we actually count the double bonds as 2 bonds, the total number of bonds broken would be 5, 10, 12, 14, 16. Again, we're counting a double bond as 2 bonds. All right, so we break them apart. And breaking a bond requires energy, no matter what you hear. Sometimes I have great respect for biologists, but sometimes they loosely say that breaking a bond releases energy. And I think that's because when ATP becomes ADP, it does release energy. But this is not happening in a vacuum. It's happening in solution, so there are solvent effects. And anyway, if you break a bond in the gas phase, it requires energy. And then let's take these atoms and reassemble them in the form of the product. So now we're going to make bonds. We're going to make 4 carbon-oxygen double bonds to form the 2 carbon dioxide molecules, and 8 hydrogen-oxygen bonds to form the 4 water molecules. And again, if we count each bond that is double as 2 bonds, we've got 2, 4, 6, 8, 10, 12, 14, 16. So we're actually forming as many bonds as we're breaking. And you might think, well, there wouldn't be any energy change, but not all bonds are created equal. And in fact, the double bond between oxygen and O2, as double bonds go, is very weak. It's almost like a single bond. On the other hand, the double bond in carbon dioxide, each of those double bonds is very strong. And so you release a lot of energy in forming the 4 carbon-oxygen double bonds, but not require that much energy in forming in breaking apart the oxygen-oxygen double bonds. So we'll show in the next clip that it requires less energy to break the bonds of the reactants than is released when the bonds are reassembled in the products. So that's the start, and we're going to go to an Excel spreadsheet next to explain this in a more quantitative way. Okay, we're back. Let's do our spreadsheet analysis of the energetics of the reaction of methanol with oxygen. All right, we're going to look at the bonds broken, and you can see in this diagram we break 6 CH bonds here, and they're not real strong, 413 kilojoules per mole. All of the energies are in kilojoules per mole. If you multiply that by 6, you get 2478. We've got the 2 OH bonds, 467, and the total is 934. 2 CO bonds. They're not real strong bonds, 358, and double that, it's 716. And as I said before, the oxygen-oxygen double bond, it's not that strong for a double bond, and there's 3 of them. And so that gives you 1494. Add it together and we get to break all the bonds of the reactants in the gas phase requires 5,622 kilojoules per mole. Well, per the stoichiometric amount, I should say. 2 moles of this and 3 moles of that. It requires that much energy to break those bonds. Now we're going to form the bonds. And we're forming 4 carbon-oxygen double bonds, which are 799, almost 800. And that's a 3196 kilojoules for those 4 moles of bonds. And for the OH bonds, single bonds go, it's a fairly strong single bond, 467 times 8. So we add it together and we get 6932. So it requires 5622 to break the bonds, but you get back 6932. So if we take how much it requires to break the bonds minus how much you get back, you get negative 1,310. The negative simply means that energy is released. 1,310 kilojoules of energy are released when 2 moles of methanol in the gas phase and 3 moles of oxygen react to form 2 moles of carbon dioxide and 4 moles of water. So it's a very energetic process, giving off a lot of energy, and hence the amount of heat released. So thank you for your attention. I hope that helps you understand the energetics of a chemical reaction.